Alright, today we're going to be solving some trigonometric equations again, except this time we're going to be using identities and a few other algebraic skills because our equations will be a little bit more complicated than what we had before. So, just to refresh, these are all on your formula sheet and you should be familiar with most of them by now. So, we're just going to go ahead and dive right into it. Now, this says find all solutions on an interval from 0 to 2 pi. Not including that 2 pi because 0 and 2 pi on the unit circle have the exact same value. So, I want you to notice something. I've got secant of x times sine of x minus 2 times the sine of x equals 0. So, this is a simple case of factoring a sine of x out, and we end up with secant of x minus 2 equals 0. And using the zero product property, we know that the sine of x has to equal 0 and that the secant of x minus 2 has to equal 0. So we can solve both of these. So sine of x equals 0. You remember on your unit circle, that's when x equals 0 and pi. And over here, we've got to solve this. Now we haven't done any with the secant yet, but we got to remember, secant is just 1 over the cosine of x equal to 2. And to solve this, I do the reciprocal of both sides. So I'll put a little 1 there so you don't get confused. So the cosine of x is actually equal to 1/2. So that occurs on our unit circle when x equals pi over 3 or 5 pi over 3. So here I have 4 solutions that work for this equation. Alright, so again, when we see some of these, you might be like, I don't even know what to do here. So I want you to look at this. Now I've got sine squared, I've got 2 of those sine squareds of w, and I got 3 sine of w plus 1. I want you to note, this looks a little bit like a quadratic. In fact, we can make it look even more like a quadratic by doing a substitution. So if I say that x equals the sine of w, I now have 2x squared plus 3x plus 1 equals 0, which we can easily factor. So I'm going to factor this, and I'm not going to go into all the details on that factoring because we've done a lot of those factorings. If you get stuck on how to factor something, just ask. I'll make sure I'll show you how I got these numbers and how we factored it. So we can go ahead and even solve for x before we plug this sine of w back in. So we get 2x plus 1 equals 0. We solve that. We get 2x equals negative 1. X equals negative 1/2. And if we solve this, we get x equals negative 1. So we've got 2 things now. We've got sine w equals negative 1/2. And we've got sine w equals negative 1. So, we look at our unit circle. Negative 1 is at 3 pi over 2. And negative 1/2 is at 7 pi over 6. And 11 pi over 6. So again, we're going to have more solutions because we have sine squared and then plus sine. So before, when we had just sine, we had 2 solutions. Here we ended up with 3. The last example we had 4. So we're looking for a few more solutions. That's why we're sticking to this interval 0 to 2 pi, just to keep things a little less complex. So again, hopefully you look at this one and you notice, hey, that looks a little bit like a quadratic again, except I don't have equals 0. So that should be my first step here. 2 cosine squared of t plus cosine of t minus 1 equals 0. And again, I think it's easier to just go ahead and substitute. If you want to use x, use x. I'm using u. Sometimes I use x. Sometimes I use... It doesn't matter what variable we use. So my cosine of t is going to be that, so I could make this 2u squared plus u minus 1 equals 0. And then we go ahead and just factor this like normal. Alright, so I get 2u minus 1 and then u plus 1. And we go ahead and solve both of those equal to 0. We get 1/2 for this first one. We get -1 for the second one, and we set cosine of t equal to that. So cosine of t is equal to 1/2. Cosine of t equals -1. And we look at our unit circle, and we see that the cosine is 1/2 at pi over 3 and 5 pi over 3. And it's -1 when we have a pi. So those are my solutions here. Alright. So those, again, the first few are all just factoring. Sometimes we'll have sine squared and cosine in the equation, which is what we have here. So we got 12 sine squared of t plus cosine of t minus 6 equals 0. Again, it looks quadratic, but there's a little thing we got to realize. I can't do this if I don't have both of these being sine or both of them being cosine. Luckily, you should already be thinking, okay, I've got sine squared, I can change that into something with cosine squared using our Pythagorean identity. So sine squared can become 1 minus cosine squared. And then I got plus cosine of t minus 6 equals 0. So I got to distribute that 12 and simplify. So if I distribute that 12, I get 12 minus 12 cosine squared of t plus cosine of t minus 6 equals 0. And then I can combine the 12 and the -6 at the end. So I get 12 cosine squared of t plus cosine of t plus 6 equals 0. So I can go ahead and do my substitution now to make it look more like a quadratic, so that it makes it a little easier to figure out my factors. You don't necessarily have to do this step, but you know, it's up to you. If you can see the factors without doing that, go for it. Some of them are more complex, so it's to your benefit to do it this way. And again, I can show you how I got all this stuff if you really don't see how it comes about. So sometimes the factors are a little bit more complicated, but in this case I set both of these equal to 0, and I get 3/4 and -2/3, which when I set my cosine equal to that, I've got a couple things. I got cosine of t equals 3/4 and cosine of t equals -2/3. You're like, those aren't on the unit circle. So that's where we do our handy dandy stuff on a calculator. So I've got a couple things. I've got the cosine inverse of 3/4, and because of the whole relationship, I've also got another angle that'll have the same cosine if I do 2 pi minus that inverse cosine of 3/4. Alright, so that's probably the most trickiest part on this. If we approximate it with our calculator, you get 0.7227, and this one is 5.56. And then we do the same thing with the other one. So these take a little bit more. I like the ones on the unit circle a lot better because it's just boom, I can look at it and find my answer. Here you have to use your calculator, and it's approximately 2.3. And then you can't forget to do 2 pi minus that cosine inverse. So just like we did before when we just had a single cosine, we had to find both solutions. So here I've got 4 answers. So it's a little bit more work because we don't have those values on our unit circle. Alright. Now, again, similar idea. I've got cosine squared of phi equals -6 sine of phi. So in order to do this, first thing I'm going to do, I'm going to go ahead and get everything on one side of the equal sign. I'm going to add 6 sine of phi. That equals 0. Now my cosine squared I'm going to have to change. So I got 1 minus the sine squared of phi plus 6 sine of phi equals 0. And you can see this is quadratic. So I'll write it like you would normally have a quadratic with this sine squared first. And sometimes, unfortunately, we will not be able to factor. And we'll have to use our good old friend, the quadratic formula. So this is negative u squared plus 6u plus 1 equals 0. And we cannot solve this easily. So we got to go ahead and do this. We do our quadratic formula. So negative b, so negative 6 plus or minus the square root of b squared minus 4 times a times c all over 2a. And we're going to calculate this out. This simplifies down into two answers. Alright. So we get one that's like really high, and we get one that's a negative number. Now, since sine and cosine have to be between -1 and +1, we cannot have this value. Alright? So, this is our u value that we have to use. So that means we've got sine of phi equals negative 0.1623. And we have to do our inverse sine again. Alright? And if we do our inverse sine of that, we get a value that is negative. And that is not between 0 and 2 pi. So since that's not between 0 and 2 pi, we actually have to add 2 pi to it for a correct value. Alright. Alright, so when we do that, we get phi is about 6.1202. And if we look at our unit circle, since that is down in the 4th quadrant, I need another angle in the 3rd quadrant that will also be the same angle. Alright, so I need to add pi to my reference angle, which is the 0.163, and that gives me another answer that is 3.305. Again, several answers, a lot of different things. Again, you might look at this and be like, I don't even know where to start. So I want you to notice something. I want you to notice I got a sine, a cosine, and then I got a sine here and a cosine here. So we're going to do two substitutions. We're going to make sine into a u and cosine into the v. We're going to do 4 times uv plus 2u minus 2v minus 1 equals 0. Now, this might not be obvious at first, so I like to use just a generic rectangle sometimes to figure this stuff out. So, if you look at this, you'll see a couple things. Number one, to get 4uv, I could do 2u, and look, 2u times 1 is going to be 2u. Alright, and if I do a 2v up top, 2v times 2u is 4uv. 2v times -1 is -2v. So this actually factors like this. 2v plus 1, 2u minus 1 equals 0. So v equals -1/2, u equals +1/2. That means I've got cosine of x equals -1/2 and sine of x equals +1/2. And that actually is easy enough to solve. So for the cosine, I get from my unit circle 2 pi over 3, 4 pi over 3, And for the sine, I get pi over 6 and 5 pi over 6. So again, there are different types of problems. I'm not doing every single problem here for you. A lot of it comes down to solving a quadratic, doing some factoring, figuring out what needs to be switched in order to make it into that. So good luck with that. I'll help ask questions if you need help. And do I have 1 minute stop?